In our next video, we're going to look at inclined planes. So we're looking at resolving forces to solve problems involving inclined planes. And to do that, it's often useful to resolve those forces in the direction parallel to and perpendicular to the plane. So if we look just at the diagram that we have here, I've got a horizontal line there, and then our surface is actually at an angle theta to the horizontal. Now, if we consider the forces acting on our block, our object there, if the surface is here, we have the weight of that object, and the weight of that object, that force there, will still act directly downwards. However, because our plane is inclined rather than being horizontal, the reaction force always acts perpendicular to the plane. So rather than having our forces opposing each other directly, we've got the reaction force perpendicular to the plane, but the force, which is the weight, is acting directly downward. So I'll just call that W for our weight. So if, just for the moment, if we consider the diagram that I've got here, and that's just going to help us to identify some angles. Now if I look at the diagram, I've got a right angle triangle here, and I've just drawn another line which lies at a right angle with our plane. So if I consider this angle at the top to begin with, now in this right angle triangle, we know the angles add to 180. Since I've got a right angle here, which is 90, these two must add to 90 degrees. And since this angle is our angle theta, this must be 90 subtract theta. So if this angle in here is 90 subtract theta, that alongside the angle in here, this angle there, must form a right angle. So if that is 90 subtract theta, this angle here must also be theta. So we've been able to identify two angles which must be the same as each other. The angle here, theta, is equal to the angle between our vertical downward line and a line which lies at this point here perpendicular to the plane. Now that's going to be really useful to us, because what we can do is, if this is our weight, I can draw a line which is perpendicular to the plane, so in the direction which opposes the reaction force. I can draw that force there, and I can draw a line here which is parallel to the plane, and I know that the angle in here must be the same as the angle theta. So if the downward force is W and I've got this angle here theta, the adjacent side must be equal to W cos theta, and the opposite side, this side here, must be equal to W sine theta. So whenever we're looking at resolving forces in an inclined plane, we can consider the reaction force acting perpendicular to the plane, the weight acting vertically downwards, which means we can resolve that weight into W cos theta acting in the perpendicular direction, and W sine theta acting in the parallel direction. So if we start to consider our examples then, so a block of mass 10 kilograms slides down a smooth slope angled at 15 degrees to the horizontal, and we're being asked first of all to calculate the magnitude of the normal reaction of the slope on the block, so that's that force R, and secondly to find the acceleration of the block. So if we start with a quick diagram just to describe that situation. So we've got our horizontal line, we've got our inclined plane at an angle of 15 degrees. So that angle there is 15 degrees. We've got our block lined up on the slope there. Its mass is 10 kilograms, we're told, and that means its weight must be 10 G, and there is a reaction force which is equal to, we'll just call that R for the moment, and that's what we're trying to find. Now, because our reaction is acting perpendicular to the slope, I need to be able to resolve the weight in the perpendicular and the parallel directions. So this angle in here is also 15 degrees from what we did earlier. Therefore, the adjacent here must be 10G cos 15, and the opposite side is 10G sine 15. And the block is sliding down the slope, so we'll just put our acceleration in that direction there. So it's going to accelerate down the slope. So if we're trying to find the magnitude of the normal reaction force, I am resolving in the direction which is perpendicular to the slope. So I'll just put that arrow there just to say the direction I'm resolving in. And if we think about our acceleration, all of the acceleration is happening parallel to the slope. Our block isn't sinking into the slope, nor is it moving away from the slope in this direction. It's only accelerating here. So since there's no acceleration in this direction perpendicular, we can say that that reaction force is equal to, so this force going this way must be equal to the force going that way. So that is 10G cos 15. So G, of course, is 9.8, so I can write that as 10 times 9.8 times cos 15. That's one that we can put into our calculator, and when I put that into our calculator, it would give us 94.7 newtons. We've got that rounded to a decimal place. So that's our answer to the first part. Our second part is asking us to find the acceleration of the block. Now the acceleration, as we mentioned earlier, is in this direction, which is parallel to the slope. So if I resolve in the parallel direction, I have got, I can use F equals ma, because we have some acceleration there. We're trying to find that acceleration. So in the direction of motion, my force, or the direction of the acceleration, my force is 10G sine 15. So 10G sine 15 is equal to the mass 10 times the acceleration a. We're trying to find a. So I've got 10 on both sides, they can cancel. So my acceleration is equal to G, which is 9.8, times sine 15, which again I could put into my calculator, and that gives us the acceleration being equal to 2.54 meters per second squared. So that's just one that we can do in our calculator, and that's going to give us our acceleration. So we've worked out the reaction force and we've worked out the acceleration. Our second example on that one then, so a particle of mass 2 kilograms is moving on a smooth slope and is being acted on by a force of 4 newtons that acts parallel to the slope as shown in the diagram. We're told that the slope is inclined at an angle alpha, where tan alpha is equal to 3/4, and we're being asked to find the acceleration of the particle. So one thing that they can do slightly differently, and we've got slightly different on this question, is they haven't given us the angle alpha. Rather, they've given us that tan alpha is 3/4. So what I can do there is I can consider the definition of what tan alpha actually means, and I can use that to find sine alpha and cos alpha. So if I just consider a right angled triangle with an angle alpha, we know that tan of any angle is equal to the opposite side over the adjacent side. So when we're told tan alpha is 3/4, we can say that 3 is the opposite side and 4 is the adjacent side. So now, since we've formed a right angled triangle here, I can use Pythagoras and hopefully we can spot one of the Pythagorean triples we know, 3, 4, this length is going to be 5. So now I've used Pythagoras within that triangle, I can say that sine alpha is going to be equal to the opposite over the hypotenuse. So sine alpha is 3/5, and I can use that cos alpha is going to be the adjacent over the hypotenuse. So that is going to be 4/5. And the reason why that's useful is because when I start to resolve these forces in terms of sine and cos alpha, rather than having to use a number in degrees, I can just find exact values for those. So if I look at my diagram, again we're going to look at the forces acting on our object P. So we've already got this force pushing our particle up the slope. I've got the weight of that particle acting down the slope. We were told its mass is 2 kilograms, so its weight is going to be 2g. And we've got the reaction force, which I'm going to call R. Now, if I resolve these forces, this side here, because this angle alpha, this angle here is also alpha, that is going to be 2g. We've got an adjacent side, so that's going to be cos alpha, and this is going to be 2g sine alpha. Now, we've just worked out the fact that cos alpha is 4/5. So 2g cos alpha is 2 lots of 4/5, or 8/5, times g. So I can write that as being 8/5g. In the same way, we said sine alpha was 3/5. So 3/5 times 2 is going to be 6/5. So that is going to be 6/5 lots of g. And suddenly our equations aren't going to need to involve us using sine and cos, because we've already kind of used those within our we've got the simplified versions of them there. So now, if I consider we're trying to find the acceleration of the particle, so I'm going to assume, and this is an assumption I'm making, that the acceleration is happening in this direction. We don't know that for certain because we've got a force pushing our particle up the slope and gravity is acting on it to push it down. So if we ended up with an answer which was negative, all that would mean is that the acceleration is actually happening up the plane. This force is strong enough to push it up the plane rather than the natural direction sliding down the plane. If the acceleration is positive, that's just going to suggest to us, like we expected, that we're accelerating that way. So that's fine. So if I resolve my forces by taking down the plane as my positive direction, we can use F equals ma. Now F is our resultant force, so I need to be aware that going in the direction down the plane, I've got 2g sine alpha, or in other words 6/5g. So I've got 6/5g, but going against that I've got 4 newtons. So I've got 6/5g minus 4. That's my force. And that is equal to the mass, which was 2, times the acceleration a. So now, if this is equal to 2a, I can divide everything by 2. So I've got 3/5 of g, 6/5 divided by 2 is 3/5. Subtract 2 is equal to that acceleration. So that acceleration is going to be 3/5 times 9.8, and then subtract 2. That's going to give us our acceleration, and if I was to put that into our calculator, that would give us that our acceleration is equal to 3.88 meters per second squared, and that's going to be our answer, and we found our acceleration there. That's the end of this video. Thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.